In today's notes, we're going to start our first unit reviewing some material that you should already know. So Unit 1 are the preliminaries that you should have learned in Algebra 1 and pre-algebra. So this should not be any new material. We will work through the notes. Feel free to stop the video and work the examples and check your answers. These are all problems that you should be able to do without a calculator. However, you may use a 4-function calculator to check your arithmetic. But do not put the entire problem into the calculator because you will be expected to do these without using a calculator. So, we're going to be talking about the order of operations today. So if you're given an expression, a mathematical expression with multiple operations, there's a certain order in which you must perform these operations so that you get the correct answer. Now the calculator knows the order of operations, so if you put it in there explicitly using proper notation, the calculator will use this order of operations to perform the mathematical operations in the correct order. So the order in which you perform these mathematical operations is that you start with the parentheses and grouping symbols first, complete those left to right. Then you look for exponents and evaluate those left to right. Then you work performing multiplication and division, again, left to right. And finally, you look for any addition and subtraction and perform that left to right. So if we look at this first example, feel free to work these examples, stop the video, and check your answers, but we will talk through all of them. In the first example, if we're following the order of operations, what would we perform first? You would look at the parentheses and you would evaluate the mathematical operation, addition, first. So I'm going to bring everything else down. So 4 times 3 cubed plus 6, and then I'm going to evaluate what's inside the parentheses to get 8. Now, at this step, I would continue to use the order of operations. So what would be the next thing we would have to do? We would have to do the exponents. So I'm going to bring everything else down. So 4 times, and then I would cube 3. So that would be 3 times 3 times 3, which is 27, plus 6 times 8. Now, in this next step, I'm looking at the operations that I still have in the problem, and I see that I have multiplication and addition. So according to the order of operations, I would perform the multiplication next. So 4 times 27 would give me 108, and that would be plus 6 times 8, which is 48. And then all I have left is addition. So 108 plus 48 would give me a final answer of 156. And we like to box our answers. So is it necessary to show all of these steps? Not really. But if you have a tendency to make mistakes, you should show all of the steps, all of your work, and to know what you're working so we can find your mistakes when we're checking your work. So go ahead and try the next few examples on your own, and I will go through how to evaluate each of these expressions using the order of operations. So in example B, I see that I have brackets, but within the first set of brackets, I see that I have a parenthesis. So I'm going to go ahead and bring everything else down. So I have 8 times 2 minus, and then evaluate 3 plus 9. And then if you want to go ahead and work the second set, you can. So in this case, if you want to just show all of your work, just bring it down. Then the next step using the order of operations would be the multiplication. So I'm going to perform this multiplication as well as this multiplication. So that's going to give me 16 minus 12 in the first bracket. Oops, let me go ahead and do that in black. Plus 8 minus, performing that multiplication, 6. Then inside of each of the brackets, I see that I have subtraction. So I'm going to go ahead and perform the subtraction. So I have 4 plus 2. And so my final answer would be 6. In the next example, I have a lot of mathematical operations. And so the first thing I'm going to do is I see that this is an isolated parenthesis, so I'm going to evaluate that. And in the second set here, I'm going to, in that bracket, evaluate that parenthesis. So that's going to be 6 quantity squared plus 1/4 times 4 minus 3 times, and then I simplify that to give me -4. Now I'm going to keep going, and I'm going to evaluate this exponent, and I'm going to get 36 plus 1/4 times 4 minus 3 times -4. Now, at this point, if you want to go ahead and evaluate this multiplication, we would have 36 plus 1/4 times 4 minus, and this would give me -12. And then simplify inside the parentheses. So I have 36 plus 1/4 times 4 minus a -12 becomes 4 plus 12, which is 16. And then I have multiplication here, 1/4 times 16, which is going to bring down the 36, plus 1/4 times 16 is 4. So 16 divided by 4, and then my final answer would be 40. In the next example, I'm going to use the order of operations in the numerator and the order of operations simultaneously in the denominator. So looking at the numerator, you're going to see what you're going to evaluate first. In the numerator, I have no parentheses. However, I do have exponents, so I'm going to go ahead and evaluate those exponents in the numerator. So it's going to be 6 times 3 squared, which is 9, plus 2 times 10 squared, 10 times 10, which is 100. That's my numerator. Now, you can keep evaluating and simplifying the numerator, or you can simultaneously be working in the denominator as well. I'm going to go ahead and look at the denominator and ask myself, well, what am I going to do in the denominator first? I'm going to perform that multiplication inside the parentheses. So that would be 2 times 9 minus 8. And then back into the numerator, I see multiplication, so I'm going to go ahead and perform the multiplication here as well as here. So that is going to give me 54 plus 200 in the numerator. And in the denominator, I'm working inside the parentheses and performing the subtraction. So it would be 2 times 1. Now in the numerator, I'm going to continue to use the order of operations, but I just have addition. So I'm going to simplify the numerator and get 254 over 2. And can I simplify that further? Absolutely. 254 divided by 2 is 127. So my answer is 127. Hopefully you got those right. Now, if I have a combination of variables, letters, and numbers, and they're connected by operations, mathematical operations, we would call that an algebraic expression. Now, to evaluate an algebraic expression means just to find the value of the expression if I were to be given some of the values of the variables. So in the first example, I have been given the fact that x equals 5 and y equals 2. So I'm going to go ahead and substitute in 5 everywhere I see an x and 2 everywhere I see a y, and I'm going to go ahead and simplify, evaluate this. So I have 2 times x we said was 5 minus x again we said was 5 times y, which was given to be 2, plus 4 times y, which is 2. Now I'm going to use my order of operations, working left to right, performing the multiplication. So I'm going to have 10 minus 10 plus 8. Continuing to simplify, 10 minus 10 is 0. 0 plus 8 equals 8. So my final answer is 8. Now go ahead and try the next few examples. Again, feel free to stop the video and check your answers. I'm going to go ahead and work through them for you though. So in the next example, I have been given the value of x to be 2, the value of y to be 5, and I'm going to substitute in those values. So I'm going to get 2 squared times y, which is 5, minus x, which is 2, times y, which is 5, and that is going to be squared, plus 3 times y, which is 5. Continuing, I now see I have some exponents that I want to go ahead and simplify. So let's go ahead and simplify those. So I have 4 times 5 minus 2 times 25 plus 3 times 5. Now I just have multiplication, so I have 20 minus 50 plus 15, working left to right. I have 20 minus 50, which is negative 30, plus 15, so my final answer would be negative 15. Working the next example, I have 4 minus the value of x, which is negative 2, times, and I'm going to turn this into a big bracket since I use parentheses to insert the value of x. So x again is negative 2, and this is divided by 2 times 6 plus, again, negative 2, quantity squared. Continuing on, working inside what's in the parentheses, or the brackets, I have negative 2 divided by 2 plus 6 plus 4. And then using the order of operations, I would perform my division first inside the parentheses, or brackets. So negative 2 divided by 2 is negative 1. Oops, that's times 6 plus 4. And that would be, continuing to work inside the parentheses, negative 6 plus 4. And then continuing on, I have 4 minus a negative 2 times negative 2. 4 minus negative 2 times negative 2. So negative 2 times negative 2 would be positive 4. 4 minus 4 equals 0. Next example, substitute in 9 everywhere I see an x, so 9 minus 9 minus the value of y, which is 1. That is cubed. Then working inside the parentheses, I'm going to go ahead and cube that 1. So I have 9 minus 9 minus 9 minus 1. Can turn these into big brackets if we want. 9 minus 9 minus 9 minus 1, which is 8. So 9 minus, and then continuing to work inside the parentheses, 1. So my final answer is 8. Now, what happens if you're given words? You're going to be working with word problems where you're going to be given words that can be translated into mathematical expressions. So for example, the number of apples. Let's call the number of apples in a basket n. Or no, let's see. We're looking at the number of apples in a basket of 12. So we're starting with 12 apples in the basket, and we're adding n to them. So you would represent that as an expression as 12 plus n. Now, the number of days it will take to walk 100 miles if you walk m miles per day. So the number of days it's going to take is 100 miles if you work m miles per day. So for example, if I say you walk 25 miles per day, that would be 100 miles divided by 25 miles per day. So that would equal how many days? 4 days. Now, if I were to give you an algebraic expression, letters, variables, and numbers connected by operations, you should be able to identify what is known as like terms. Now, for terms to be like, they have to have the same variable factor. Same variable factor. So if I'm looking at this, what would be some like terms? Well, I see an x squared term. That's an xy. That's just a constant, a number. Oh, and another x squared term. So like terms would be 3x squared and 4x squared. I could combine those. Now, what would be known as your constant terms are just your numbers without variables in this case. So what would be your constant terms? Well, 2 and -1. Now, if you have a term that is written without a coefficient, well, coefficient is a number connected to a variable by multiplication. So, for example, if I were to give you x squared, so that is a variable term without a coefficient, we know that the coefficient is 1. So I don't have to see it, but I know it's there. So if I give you an x squared, I've given you 1x squared. Now, what happens if you have a term that is written without an exponent? So for example, what if I give you an x? What would we understand the exponent to be? Well, if we don't see it, we know it to be 1. Now, these are things that are obvious, but we need to explicitly state them because when we use them later in more interesting math problems, we can't forget these things. So what happens if I give you a term that is written without a denominator? So let's say I give you a 4, or I give you an x. What is the denominator understood to be? Well, it's understood to be 1. So if I don't see it, it's there. So let's take all this information about like terms and constants and exponents and coefficients, and let's see if we can simplify each of the given expressions. So I'm going to combine like terms. So what are like terms? 3x squared and 4x squared. If you want to rewrite it, so you put those like terms together with their operation, you can. You don't have to. You can go ahead and combine them. But in this case, if I were to combine, I have 3x squared, and I'm going to add another 4x squared. That's going to give me 7x squares. Now, can I combine anything else? Do I have any other like terms? No. So that's my final answer. Now, in the next example, I'm going to have to use my order of operations first. I see, before I can combine like terms, that I have to distribute this little -3 to each base factor inside the parentheses. So if I were to distribute that -3 by multiplication, I would get -6x plus 3xy minus 9y, and then I'm going to go ahead and bring down that -11xy. Now at this point, I just have addition and subtraction of these terms, so I can go ahead and combine like terms. So let's look for some like terms. Well, these two terms are like. So I'm going to go ahead and combine those. Again, if you want to rewrite it first, you can. If you want to go ahead and combine them as you go, you may. So if I have 3xy and I take away 11xy, that's going to give me minus 8xy. And of course, don't forget you have this minus 9y. Now, are there any other like terms? No, so I'm done. Now, let's go ahead and take a look at an application. Holly's hybrid car gets 45 miles per gallon on the highway and 25 miles per gallon in the city. You are being asked to write and simplify an expression for the total number of miles she can drive if her fuel tank holds 15 gallons of gas. So the total number of miles she can drive, is going to equal, well, those 45 miles per gallon on the highway plus 25 miles per gallon in the city. So that's our first expression. Now, I know she has 15 gallons of gas. So she has 15 gallons of gas, and that is to be used on both the highway and in the city. So those are some expressions that I can use to represent the information that I've been given. Now, I've been asked how many total miles can she drive on one tank of gas if she uses 5 gallons on the highway. So this represents what? Our H. So if I use the first expression for the total number of miles, remember the total number of miles equals 45 times H in this case, which is 5, plus 25G. So I can solve for what? Well, I have only 15 gallons. And remember, that is equal to 45 times, well, I have 5 gallons on the highway plus 20C, or G, however you want to, in the city. I called it G for the gallons in the city. I can solve for the number of gallons I have in the city. So what is C? C is going to be, or G is going to be, well, if I have only 15 and I've used 5 on the highway, I only have 10 for the city. So I can substitute that back here to give me my total number of miles. So my total number of miles is going to be 45 times 5, which is 225, plus my 25 times 10, which is 250. So my total number of miles is going to be 225 plus the 250. So this is a word problem, so I'm going to say that the answer in a sentence, total miles she can drive is 475 miles. There you have it. So again, none of this should have been new, and hopefully this all makes sense. If not, feel free to ask us questions.